All right. Good morning, everyone. Welcome back to a lot of you. Welcome to day 4 of the AABC virtual annual meeting webinar series. We do not have a video to play for you today, so we're just going to get right into the quick Zoom instructions and then get on with our program. As a reminder, a lot of you are old pros here at this point, but if you have a question for our speaker, please use specifically the Q&A function in the Zoom window toward the bottom. Reserve the chat function for if you're having any kind of technical difficulties. Please put anything like that in there, direct it to the panelists, and our technical specialists will address that as best they can. So for today's presentation, we do have Mark Harte with Daikin speaking on variable refrigerant flow, VRF or VRV systems, function, testing, and monitoring. Just a little bit about Mark. Mark joined the U.S. Marine Corps right out of high school and spent some time traveling the world as a jet engine mechanic, working on the RF-4B Phantom aircraft. Later spent 20 years working in the field as an HVAC contractor and eventually landed at Daikin, where he is the technical training manager for them. So with that introduction, I'm going to hand you over to Mark. And Mark, take it away.
Thank you, sir. How's everybody doing today? I know we can't respond, but thanks for that. As you can tell by Ray's introduction, I'm an older guy. I've been around a while. I've been with Daikin for 14 years. So what we're going to talk about today is we're going to talk about VRV systems, variable refrigerant volume. A little different from VRF as far as the functionality, and we're going to talk about a lot of those things. We got a lot of information to cover. So we're going to go through this. We're going to start right away. Like Ray said, if you have any questions, put them in the Q&A, and we will cover that at the end. We will go over any questions you may have. Oh, excuse me. Let me get it active here. So that is our facility at Houston. That is our new facility. That is a 4.2 million square foot facility. I believe the largest tilt wall construction site in North America. It's a big place. I live about 5 miles from there. I haven't been there in about 7 months due to the issues we have going on. A little bit about Daikin as we get started. A little bit of a timeline of what we produced, when we produced it, and where we're at now. As you can see, DTTP, Dallas, Texas Tech, or Daikin, Texas Technology Park. That is an bird's eye view of the facility. Like I said, it's a 2.2 mile walk around that facility. It's massive. It's a one-stop shop, everything in-house that we need. You can see some of the VRV products we have come out with. The new one we launched last year, VRV4X, is what is currently being sold in the US. So that's just a timeline, just to show you that Daikin's not something new. We've been around since actually 1936. Some of the other corporations that Daikin has acquired, we acquired Goodman. We bought McQuay, 2004, 2003. And along with McQuay came J.E. Hall, along with Goodman came Amana, and along with McQuay came American Air Filters. So some of the stuff we have across the industry. Daikin North America is just our vision. Right now, we sell everything from a 2-ton mini split up to massive chillers. Daikin Applied is also what used to be the old McQuay. So we cover everything, residential, commercial, we have water cooled, we have chillers, we have everything. That is a front view of the Daikin DTTP. It's faster to say it that way. That's where I'm in Houston. I moved here from the California office about 3.5 years ago. So that's the building I usually go to. But right now we're doing essential personnel in there due to the COVID situation. Daikin University. Daikin City is our website. If you go on the web and you go Daikin, you'll get the global website. If you want to look at Daikin North America stuff, it's Daikin City. You can go on there, you can join it. You can get all the information you need, install manuals, operation manuals, engineering manuals, anything you need. This is also where Daikin University is at, and that is our school, basically, where you can go in and register for classes, look at what we have to offer. If you want to take courses, you get certificates. Most of our courses are NATE certified, and some of our courses are AIA certified also. Now, let's get right into the equipment. So we're going to start with the outdoor units. As you see, this technician, he's got his laptop hooked up to. There's several things we can do with the laptop. Now, as far as the model numbers of our outdoor units, we make two styles, if you want to say that. We make a heat pump and a heat recovery. A heat pump is a straight heat pump. It's a two-pipe system that you can heat or cool. You can do multiple fan coils of our systems. We can do a triple module system where you have 3 outdoor units piped together, and we can go up to 62 indoor units off of these, depending on, of course, their capacity. The smaller unit you see to the left there, that's a VRV Life or a VRV 4S. That's more of a light commercial residential application. They go up to 5 tons. But the nomenclature, if it's a heat pump, it's going to be an RX. If it's a heat recovery, it's RE. Easy to remember. If it's recovery, RE. And depending on the voltages, we have 575, 460, 28, 230. We do 575 for the Canada market, of course. Right now, everything's 410A refrigerant. And you see down here, we also have a water-cooled system. So if it has a W in the model number, it is a water-cooled system. So heat pump, heat recovery, and water-cooled. Now, a typical layout of a heat pump system, you have the outdoor unit, number 1. Then you'll have your indoor units, 2 number 3s. Now, the refrigerant piping, we'll talk about the circuits you see there where they split off, and you have we're going to talk about Refnet fittings in a little bit, refrigerant network devices. They're basically refrigerant wires that split so we can pipe all these fan coils off of one condenser or we call them outdoor units, excuse me, not condenser, because they can be an evaporator too. 1, 2, 3 outdoor units. We can twin 3 together depending on the capacity we need. And then down you'll see number 4 is what we call our remote controllers or thermostat. We call them remote controllers because they interface with the fan coils. And we're going to cover them a little bit longer down, a little further in the presentation. We'll talk about remote controllers and some of the things we can do from the remote controllers as far as field settings. Now that's a heat pump system. Now when we talk about a heat recovery system, you'll see another component in there, that number 3 component. That's called the branch selector box, okay? This, with a heat recovery system, this will be a 3-pipe system. You'll have 3 pipes coming off the outdoor unit. You'll have a liquid, a true suction. It'll always be a cold gas line. Then you'll have a high-low pressure line. That's the one that's going to switch over depending how much, if you have a call for heat or cool. The branch selector box, you could think of it as a 4-way valve. So anything downstream of that branch selector box, like in this case, you'll see the first branch selector box, and down below that is an indoor unit. That indoor unit can heat and cool independently of the other indoor units. So that's how we get heating and cooling at the same time off of the heat recovery system. Now you see the second BS box, the number 3, it's attached to 2 fan coils through the refrigerant piping. Those 2 fan coils cannot heat and cool independently because they're after the branch selector box. So that you don't have to run them at the same time. They can be, you can set them both for cool. You can set different temperatures. You can turn one off, run the other one, but you can't heat and cool at the same time with those 2 fan coils since they're downstream of that box, the branch selector box. So you want to think of the branch selector box as downstream as a heat pump. That's the best way to think about it. And then, of course, we have different types of remote controllers. We have a wireless that's available. We this number 5 down here in the right corner under this ducted fan coil, that's a simplified controller. We do also have new controllers coming out now. We have the Daikin 1 Plus that's more user-friendly. That's more for the residential side, but it can be used commercially. We have an ATC controller coming out for VRV. There's a lot coming out. Just some examples of the outdoor units as far as placement. I want to make sure all the air is discharged away from the outdoor units. Now we can change the static pressure on the outdoor units, so you can put them inside of a building and duct them out. And I think the next slide shows that. This is just showing an example where they had the outdoor units down in a well on top of the building, and all that hot air during AC was recirculating through the outdoor unit, which is bad. We don't want that because it's not going to perform efficiently. So they elevated the units. They could have also ducted those outdoor units and put the ductwork at the top of that well and had it disperse out that way. This is an example of how to duct the outdoor units if they're inside the structure. And we can change the external static pressure of that outdoor fan motor. Come set at 0.12. We can change it up to 0.32, depending on your ductwork that's hooked to it. This is a field setting we do from the outdoor unit. There's two types of field settings. We're going to talk about them. One from the indoor remote controls and one from the outdoor unit. The difference would be the ones you do with the indoor remote controls affect the fan coil or indoor unit or indoor units that are connected to that one controller. We can hook up to 16 indoor units to one controller if need be. If you do anything field setting from the outdoor unit, it will be on the printed circuit board outside, and I'm going to show you the buttons in a little while. That affects the whole system. So that's the difference between the two field settings. Now, as far as piping, I'd say about 85 to 90% of our indoor units are flared connections. They are flared. There's a couple, the vertical air handler and the bigger fan coil, the 6 and 8 ton, the FXMQs, they have a brazed joint on the suction line, but most of our indoor units have flare connections. And you're going to see a toolkit that you can get through Daikin reps and distributors that gives you a proper flare tool, gives you gauges, torque wrenches to torque down the flare nuts. Now, if a flare is done properly, it is not a problem. I've got buildings that have had flares in them for 14, 15 years with no leaks, as long as it's done properly. Now, this kit is available. I'm not trying to sell tools here. I'm just showing you, but that flare gauge, that black tool right there, is worth its weight in gold because it checks the flare once you do it. So this is just a process of how to properly do it. 85 to 90% of the problems we see in the field with VRV is install related. So you want to make sure the flares are done properly. And this is just, and like I said, we offer a lot of training on this. When guys come in-house, they actually do flares in the in-house training. Now, some of the piping rules that come with VRV, as far as lengths, vertical separation, you can see, look at the total linear length. You can go 3,280 feet of refrigerant piping. Now, that's one way. That's one line. And remember, on a heat recovery, that's a 3-pipe system. So, and then vertical separation, we can go up to 295 feet in certain applications, 195 feet in certain applications. Height difference between indoor units on one system. That is a key right there. For years, we had 50 feet. Now it's 100 feet. So one system, you could have 100 feet. What is a building? Usually 10 to 12 feet per story. So one system could cover 10 floors with just those fan coils. These are piping rules. When we teach guys in class how to do the piping, we show them these, but there's a report you'll see coming up in a little bit. It's called the Web Express that does all the piping rules. It's done by the engineers and the salespeople. And I always tell guys, do never install a VRV system without that Web Express program. And you'll see why a little bit. And this is just showing some of the rules. Like I said, this is straight out of the install manual, and it just shows you. So we want the contractors to be aware of this. We want everybody to be aware of this because, you know, certain problems are application problems. Maybe the vertical separation is too large. You know, maybe it's you've got too many fan coils off the system. So we make sure they're familiar with the rules. Now, as far as the outdoor unit, there's many ways to run the refrigerant piping off of it. You have many options. I see a lot of guys come out the bottom because if you run it out the front and guys are working on it, first thing they're gonna do is stand on that refrigerant piping. So you can run it out of the bottom, run it straight out the back. There's many ways to do it. There's a knockout panel in that outdoor unit. You just knock it out and you can run the refrigerant. And there's a kit that comes with it. It gives you 90s and some pipe extensions to run that refrigerant piping. Now, as far as outdoor units, manifolding them together. Now, this is a heat recovery. We can do a single module, a double module, or a triple module. Now, when you pipe these together, in this case, as a triple module, there's a kit you put together. This is not the Refnet I was talking about earlier. That's for the indoor. This is for the outdoor. We call this a branch kit. It's like you have 2 pipes that go into one. So basically, if you have a double module, you would get this kit, and it would have 3 pipes in it for heat recovery. It'd have a liquid, a suction, and a high-low pressure line. If it's a triple module system, you would need the other kit. So we have different part numbers. It's bigger piping because you can imagine when you pipe all 3 of these together, that final piping leading there is going to be rather large depending on your capacity. It could be 1 5/8, 1 3/8. So these are the kits that they use. There's your valves on the heat recovery. As you see 3 valves: liquid, true suction, then the high-low pressure line. This is the only line we'll ever have hot gas or hot discharge gas going down it. This suction line will always be a true suction line, a true cold gas line. And of course, the liquid is always a liquid line. Now the Refnets, this is for the indoor units, for inside the building. Let me rephrase myself. This is what they look like, and they come in 3 different sizes. That foam you see wrapped around them is not packing material. That's actually your insulation for inside the building. If you guys have contractors or somebody's installing, tell them not to throw that away. That's what you're going to insulate it with. We have 2 styles. We have a wide joint. So your main branch will be coming in here, and then your main branch heading downstream to catch more fan coils going that way. And then this branch would go off and catch a fan coil. And as you can see, they're stepped, so you can cut them to the size of the pipe that's going into it, because your pipe's going to change. As you go downstream, your pipe's either going to stay the same size or step down. We also have headers. Maybe you have a room that has 4 fan coils, and you don't want to have 4 Ys. You do a header, so you come into that header and you can run off of there and hit your 4 fan coils. It comes in a 4 and an 8 branch header, and that's a dead end. You do not cut this end off and go further downstream. And that is not packing material. That is also the insulation for that header. The liquid line will come with 90s already on it, and there's certain ways to install them. The headers have to be flat and horizontal. You cannot stand them up. We're going to talk about the Ys here next. So putting in the Refnets, the Y joints, going vertically, doesn't matter. You can have if the unit's above, if the outdoor unit's above, of course, the main pipe would be coming down this way, or if the outdoor unit's below, you would come up this way, all right? But if you put them in the horizontal position, no more than a 30-degree angle either way. That's very important, because you will starve fan coils of refrigerant if you do more than 30 degrees, like this with the big X on it. Big X usually means no. Yeah, you do that, you're going to starve that one branch of refrigerant. And we have a service tool called the service checker. Actually, you can see superheat from the remote controls of the fan coils, and I'll show you that in a little bit. So that's a very important thing right there. If you guys are going to a job site, you're doing inspections or whatever, make sure those Y joints no more than 30 degrees. Now this is the Web Express report. As you can see on it, it shows you the outdoor units and their model numbers. It shows you the branch pipe kit for the outdoor units, gives you the model number there. Shows you the pipe of size of the pipe coming off the outdoor units, then the pipe going inside. And then it's going to show you the Refnet kit part number that you'll need in each location. So coming in here, this is a heat recovery because we have branch selector boxes. If it was a heat pump, there would be no branch selector boxes. And coming in there, it shows you the pipe size in and the pipe size out going to the indoor units. This is a multi-port box. That's why you see 1 box, but you see 3 outlets. This is a 4-port box. We have 4, 6, 8, 10, and 12 multi-port boxes. So that's why it just shows 1 box there, but it has 4 ports, and they're not using port D, so there's no piping coming off of this. This is called the Web Express report. Make sure if you have contractors or anybody installed that they have this report in there, and tell them to get the colored version. If it's all black and white, some of the numbers as far as the pipe size kind of melt together and you can't read them very well. Now, some of the rules as far as piping, the Web Express takes all these rules into account. So when the engineer or the salesperson does a Web Express program, he puts in the pipe lengths. If any of these rules are exceeded, it'll give them an alarm saying you can't do that. So they have to redo it to make sure that all the rules are met. That's why the Web Express program is so important. Any job, whether it's 1 fan coil with a 6-ton outdoor unit, or 62 fan coils with a 38-ton triple manifolded system, make sure the Web Express is done. So this goes over some of the rules, and when we teach you guys in class, we don't expect them to remember that, but we want them to be aware of it. Now, the tool bags that you can get from distributors, these are actually put together for me by Bigfoot. I've been working with them for years because we use Bigfoot stands up with our outdoor units. They're a nice little tool set, gives you everything you need. I'm not trying to sell tools. I'm just showing you, proper tools make for a better install. They can use whatever tools they want as long as they're the right ones. You get torque wrenches, deburring tool. Deburring refrigerant piping is massively important. When they clean it out on the inside, they've got to deburr it, because if you don't, you'll get turbulent flow. Torque wrenches, gauges, manifold sets, adapters, service. So it's a handy. There's a commercial. This is a commercial bag. This is a residential bag. Pressure testing. Why did I put this in here? Because it is very important. Nitrogen pressure, dry nitrogen pressure testing. Want to pressure test because of the massive piping lengths we can do. We want to make sure we have no leaks. And you see it's a triple pressure test, 150 PSI for 3 minutes, 325. Now, two differences between these two PSI values, 450 PSI, if either one of these, this indoor unit, the FXTQ, or the coil, the CXTQ, because now with VRV4X, we can do all gas furnaces with coils on them. So in VRV Life, which is residential, also uses coil. These are made in the US, these aluminum coils, they're not rated to the 550 PSI. So any of those are in a system. I don't care if it's 62 fan coils, you have one of those in there. The max PSI pressure test is the 450. If you don't have either one of these, you go up to 550. And if it's a commercial job, I recommend holding it for 24 hours. Why not? Worst thing to do is have leaks. You know, leaks are callbacks, leaks are problems. Leaks lose oil in the refrigerant, leaks lead to massive problems. So we want to make sure we have a tight system. And when they pressure test it, dry nitrogen. Wiring at the outdoor unit. Now this is low voltage wiring. If you have a manifolded system, like here, we have two outdoor units. One will be your master outdoor unit. One will be a sub. If we had another one, that would be sub 2. How is the master unit determined? It's the one where the low voltage wire from the indoor lands. It automatically does it. So if you see here on the sub unit, all you're doing is twinning these together with this Q1 and Q2 right there. That just twins those units together. F1 and F2 to indoor unit, it even says it on the unit. That's where you would run your wire. So that makes that unit automatically the master unit. So all the programming you do, all the field settings you do will be done from the master unit. If you did any field settings from this unit, they wouldn't take effect. So that's how we determine which one is the master. Now this F1 and F2 says to outdoor unit, that's going to be for the centralized controller, be it going to a backnet, to a lawn, to our iTouch manager. And what you would do is each system, say I had 4 systems on there, I would daisy chain the outdoor to each system, then run that wire to the front end, be it the backnet, lawn, or the ITM. Now, key thing, our low voltage wire that we want you to use, 2-wire, stranded, non-shielded, 18 gauge. That's all you need. 2-wire stranded, non-shielded 18 gauge. We don't need a shield. Shield is just an antenna to pick up interference. If for some reason, and it says it right there on the bottom of that page, if for some reason they run shielded wire, you would have to ground each end of that piece of shielded wire. And we just want a smooth daisy chain, no splices, no star joints, just a smooth daisy chain. Like I said, it's 2-wire. That's a 16 volt DC communication circuit. It sends data packs back and forth. Splices, wire nut connections, they are bad for that communication. So that's all we want. So it's a very simple low voltage wiring. We call that the D3 net. D3 net is our low voltage circuit. This just shows you an example of the terminals, actual pictures. You have F1 and F2 that says to indoor. You would run that to each indoor unit. And at each indoor unit, you have 3 terminals. F1 and F2, that's going to be your daisy chain from the outdoor. P1 and P2 will be your remote control wiring, as you see down here. T1 and T2 is a forced off. We could tie in a float switch to that. It is not fire life rated. It is not designed for fire life rated, okay? A lot of guys want to tie smoke alarms or smoke detectors into that. And you cannot apply voltage to T1 and T2. It's dry contacts. It's mainly designed for float switches. We could do occupancy sensors on it. There's a few other options we could do with it. Now here's the wiring report you get with the Web Express. So you get a piping report and a wiring report. And it shows you how to wire it up. Shows you the outdoor units, the wire run to, now this is a heat recovery, so the BS boxes are in the low voltage circuit, as you can see here. So you got the outdoor units, and then we daisy chain those BS boxes together, okay? Then off the BS box, we go to the fan coil that it's connected to, and then to the remote control. And this is all the same wire, the 2-wire stranded non-shielded. All this wire is the same. And you can see here, it also gives you the voltage that you'll need. There should be a voltage on there yet. Now it gives you the amperage that you'll need on those. So this is the low voltage. And you see on the multi-port box, you would wire the low voltage to the same port that the piping runs from. So there's a port A for piping and a port A for wiring. So port A piping would go to this indoor unit. Port A wiring would go to that indoor unit. It even gives you the model numbers of the specific indoor units that are going in that location. So as you can see, the web express report is very important, very important. All right. Let's talk about indoor units. Indoor units. I know that it doesn't make sense, right? Those are outdoor units. Talk about indoor units. We have a lot of different indoor units you can use on VRV. Like I said, with VRV 4X, you can now do gas furnaces. But the key thing on that is if you're doing gas furnaces, all the indoor units have to be gas furnaces. You can't intermingle the other fan coils here with the gas furnace. It's got to be all gas furnaces with the coil, and then it'll do a heat pump lockout and bring on the gas furnace. Now we have an ERV, energy recovery, an outside air processor, and we'll talk about that in a little bit. Now our ducted fan coils, these are all ducted. This is low static. You're not going to get more than, I think, 0.16 static off of this when you change it up to the higher static. Now the FXS, the medium static ones, we can do an auto static setting, and I'll talk about that in a little bit. So this will be the SQ and the MQ. So these two are almost the same style, but you get more static out of them. Now we have a large fan coils, the 6 and 8 ton, the high ESP, these, and their static is basically a toggle switch on the control panel of that indoor unit. And I have a picture of that coming up. And we have a multi-position vertical air handler. It's ECM motor, so there's not really any static settings on that. Those are our ducted styles. Then we have non-ducted. You're not doing a lot of static settings on the non-ducted, of course. Cassette style wall mount under the, under the ceiling, 4-way cassette, nice. Floor mounts, 2 style, ones you could put like behind the wall, like say they had radiator heat in the building. These are very nice for that. 1-way blow, so that's a cassette that goes up in the ceiling. Ceiling suspended, this will hang underneath the ceiling. We have 2 styles of cassettes, a 3x3, which has 360 round flow. And then this is rather new, the Vista. This is very nice cassette. It's smaller. The biggest it goes is the 18,000 BTUs. So many different styles of non-ducted fan coils, or ductless, excuse me. Now, branch selector boxes. We have multi-ports and we have single ports. So multi-ports, you have many ports off of this. We have a 4, 6, 8, 10, and a 12. And then the single port boxes, in some places, you have the 3-pipe coming in from the outdoor unit, then you'll have the 2-pipe going to the indoor unit. Maybe you have a room where you don't have multiple fan coils and you have 1 box, but it depends on the application when you use a single port. We also have a new BS box coming out this month called the Flex box, which will have 3 pipes in and then 3 pipes out. So the use of Refnets is going to reduce because you can come in with the 3 pipes and then continue on out of that branch selector box to the next box or to the next fan coils. It's called the Flex box. If you want to look at it, it's on Daikin City. You can look it up there. Low voltage wiring. Most of the fan coils are the same. They have the P1, P2, F1, and F2, and the T1 and T2, and they're all 208, 230 single phase, all of them. You have L1, L2, and ground, okay? There's certain ways to run the wire in there, but they're all going to be 208, 230 single phase. 3-phase will be the outdoors. We don't have any 3-phase indoor units as far as VRV. That would be if you talk about Daikin Applied. Some of our fan coils have float switch connectors where you can tie in condensate safety. And you see, depending on the model number of the fan coil, you have a jumper that you would just cut into and splice into it. So that way, you can just tie your external safety. This would be for our external condensate pumps, not internal. Some of our fan coils have lift pumps in them. They're designed to lift the water up to a certain height to hit your main building drain. This is for external condensate pumps, ones you are adding to the system, because you'll see the coils we are showing here are all gravity fed drains. That's why they have these jumpers in case you need to tie a pump into them. They're all gravity fed. They do not have lift pumps in them. Now, let's talk about outdoor, indoor. Let's talk about remote controllers. Okay, we're doing good on time. Now, remote controllers, I mentioned earlier, 16 volts DC is our communication circuit power, okay? It's 2-wire, their data packs going back and forth. We want a nice smooth daisy chain. We can do a lot with these controllers. So I call it the D3 net. That's our protocol. That's what we talk about when we're talking about. It does a lot. When you first power up the unit, we're going to talk about that during commission. It goes through and auto addresses these things, the indoor units. We can do a lot from the remote as far as looking at functions of the fan coil, changing functions of the fan coil, and looking at sensor values. No rotary or dip switches. The only dip switches will be on the BS box, the branch selector box, depending on if you're using a port or not. But other than that, it does it automatically when we power this system up. So it's just showing you here the same thing I showed you earlier, the wire connections. Now that's a VRV, that smaller unit to the right there is a VRV4S. That is not, that doesn't come in heat recovery. It's in heat pump only. It's like commercial residential, but it has the same communication leg, and you can use all those fan coils I just showed you also on the VRV4S. It's not limited. It's the same fan coil, same indoor units. Of course, less capacity because the largest this comes in is a 5-ton unit. On the heat recovery and heat pump, I think we go up to 38 tons or 42 tons, depending on what you manifold together. Like I said, it's a smooth daisy chain we want, and no splices. Splices are bad. We don't want splices. Smooth daisy chain. The types of controllers we use, the nav controller, the one on the left there is probably the most popular right now. Like I said, we're coming out with newer ones, but it's very user-friendly, and there are features you can do with the simplified. Depending on your application, it has limitations, but it's very sturdy. It's very reliable. I've been with Daikin 14. I think I've only replaced like 3 of them, and it's usually the red light that goes bad in it. But it shows set temperature, not room temperature. So if you do assisted living facilities, it's very good for that because they think it's 72 degrees in there. The wireless controller, I don't see a lot of that used with commercial jobs. And our ductless mini splits have their own wireless, so I don't see that used a lot. Now, field settings. This is what we do from the indoor remote controller. There are field settings. We can go in there and adjust how fan coils operate. We can adjust what sensors they look at. Each fan coil has a return air sensor, and there's a sensor in the remote control. We can make it so it can just look at the return air sensor. Say you don't want that controller in the space, you want to put it in a maintenance room. We can make it so it just looks at the sensor in the remote control, so it controls by that sensor. Or you can use both of them. It doesn't average. It works, say you have a 72-degree set point. Once that return air sensor gets within 2 degrees of that 72-degree set point, it converts control from the return air sensor to the remote controller sensor. But if you're bringing in fresh air, it's going to affect that return air sensor. We also have a remote sensor that you can use. Say you unplug the return air sensor in the fan coil and put the remote sensor in a space. It's a little 1 inch by 1 inch block, and it's a sensor you can remotely locate. But the field settings we do at the controller affect only the indoor unit or indoor units that controller is hooked up to. Many things we can do. It all depends on the type of indoor unit. If it's a ducted one, you're not going to adjust louver angles like you would on a cassette style. So there's many field settings we can do from the controller. Now this is an example of some of the field settings we can change. These are mostly, these settings right here are they're going to change what you see on the controller interface. As you can see, they're all about icons, day and clock, set point display. So we can change that display so all you see is on and off and the room temperature. So you can make it very user-friendly. You can change it so it has big numbers, for the people of my age that are hard to see stuff. So there's a lot we can do with that navigation controller to adjust the fan coil operation. Also, you can see each fan coil has a liquid line sensor, a gas line sensor. All of them have return air sensors except for the vertical air handler that has no return air sensor, and the CXTQ, that coil I showed you that went on top of the furnaces. All the others have return air sensors. We can see those 3 sensors from the controller. So if that fan coil is in air conditioning mode, you can go to that remote controller and you can look at that liquid line sensor and that gas line sensor, and you can see the superheat of that particular fan coil from the remote controller, because the liquid line sensor is after the expansion valve. It's not before it, it's after it. So we're going to start metering there. So that's going to show us the saturation, liquid and gas going into the fan coil. So it's also a service tool. So there's a lot, but these field settings deal with what you show on the display of the controller. Now you can lock it out to prohibit anything. So if you get it set up, you don't want the end user, say it's commercial, to get in there and mess with anything. You can go in there and it's, my guys call it the 4-finger death punch. You lock it. We don't advertise this in our install manager, operation manager. This is for the contractors, you know, because we show this to the end users. What's the sense in locking it out? So it's a sequence you do, and you can lock it out. And every time they hit a button, whatever, and you can select what buttons you want to lock out. You don't have to lock out everything. And on the right, you'll see that little red circle with that lock symbol, or that key, excuse me. When they try and change something's locked out, that key will pop up. You can make it so that key doesn't show up, so they don't know why it's doing it. So a lot of things you can do with the nav controller. As I said, you can see sensor values from the nav controller. There's in the field's indoor unit status, you can go in there and you can look at the sensor values, return air sensor or remote sensor, depending on which one you're using, your liquid line temperature, gas line, your discharge air temperature, if the fan coil has it. We only have one fan coil that has a discharge air sensor. So like I said, it's a service tool also. That's very handy. No more going to the grills, you know, checking your air temperature. If you've got superheat, you know the fan coil is performing properly. And we're trying to maintain around 9 degrees of superheat on our indoor units. All right, commissioning, starting up the system. In the outdoor unit, you're going to have a PCB with a 7-segment LED display. You see it on the top left there, right here with 3 buttons. All right, that's where we're going to do all our work as far as commissioning, depending on what we want to do. Now, any field settings we do from this PCB here affect the entire system. Okay, they affect everything. So if it's a single module, triple module, or a double module, you know, it's going to affect that system. We'll talk about those. And then you'll have your high voltage hookups, and then of course your service valve. As you see, this is 3 valves. So you know right away, if you see 3 service valves, it's a heat recovery system. But these are what we use to count indoor units, count BS boxes, set certain parameters of the outdoor unit, changing the static pressure of the outdoor fan motor we would do from this PCB. Now, some of the things, this is what we call a pre-commissioning checklist. We want to make sure that all this stuff is done before we start it up. There are brackets on the compressors that need to be removed, stop valves securely closed, refrigerant piping pressure tested, triple evacuation. Evacuation is key. It's key. You've got to do a good evacuation. If guys aren't using micron gauges and there's so many different evacuation pumps out there nowadays. With oil, you can change as it's running. There's no reason not to do a good evacuation. Really not. The better the evacuation, the better that system's going to run. Trust me. I've seen so many issues where guys don't do it properly and they have problems down the field. All liquid lines are measured. In the class, we teach guys, you can calculate the additional charge because you're always adding charge to a VRV system. It depends on the length of your liquid line. And there's a couple other parameters. In the install manual that comes with the outdoor unit, it tells you exactly how to calculate the additional charge. But the Web Express program, once you fill it in and put all the pipe lengths, it'll tell you what your additional charge is. All right. Everything's installed, everything's insulated, everything's ready. So we go through this with the guys to make sure, you know, everything's ready. When you're ready to start it up, we need everything done, you know, filters in, all that good stuff. Now, I always tell the guys, the first thing you want to do, well, you want to power up the outdoor unit the day before, probably because you want to warm that crankcase heater up that wraps around that compressor so we can boil any refrigerant out of that oil. That's the first thing. We recommend 6 hours, you know, to boil that refrigerant. You might get a fault code on the indoors because you powered up the outdoor and the indoors don't have power. It doesn't matter. That's not going to bother you. Because when you come back, what I tell guys is okay, what I would do is I would go upstairs or wherever the outdoor units are, turn them off, go inside, turn all the indoor units on, then go back and turn the outdoor unit on. When you do that, it's going to start reinitializing. It's going to, initialization. It's going to go through an initialization process where it's going to go in and count indoor units. It's going to count BS boxes. It's going to auto address the indoor units. Now this, what you'll see on the LED display, what you'll see here is during initialization, you'll have half zeros or zeros here. You'll see 3 of them and they'll be flashing. Okay, this is journey. Don't do anything. Don't hit any buttons. Don't do anything. You don't need to. It's going through and looking. Near the end of initializations, those 3 flashing zeros will turn solid. Okay, that's good. You want it to do that. Okay, When it's done initializing, that display will go blank. So that's good. That means there's no issues at this time. Okay. Now notice the 3 buttons underneath here. We have mode, set, return. This is where we do all our field settings for the outdoor unit from those 3 buttons. Okay. You want to make sure that the remote controllers inside are turned off because we're going to run a test operation after we count indoor units, make sure we have no error codes. If they're in cool mode, that's fine. But I recommend, guys, just go in there and turn them off. You don't need the controllers on, okay? Because the test mode, I don't care what temperature is outside. Test mode is always done in air conditioning mode, always. And you'll see that in a second. But this, like I said, anything we do from the outdoor PCB affects the entire system, okay? This is where we can change, what can we do from the outdoor PCB? We can count how many indoor units there are. We can count how many BS boxes there are. That way you know if you have the correct count or not. If we're not counting the proper indoor units, there's a force fan mode we can do from there. That'll force all the indoor units on at high speed. The ones you're not counting won't run. Walk inside the building. Say you walk down, say you have 40 fan coils. Okay, I've gone through 20. Oh, 21's blowing. Oh, 22's not running. Where do you think the issue might be? Probably between those two. Maybe somebody didn't turn power onto that fan coil. Maybe they didn't wire it up. So it's a great troubleshooting. It's also a way to identify what units, fan coils are on a system. Say you're in a building that has 8 or 9 systems, and you don't know which fan coils are tied to which outdoor units. You could do that. There's also refrigerant recovery mode. You can go to that outdoor unit, and it's a sequence of buttons you hit. What it will do, it'll open up every expansion valve at the BS boxes, at the indoor units, and at the outdoor units. It gives you a wide open refrigerant circuit. Why is this key? For reclaiming, if you have to reclaim it. Say you're installing it and the electrician powered up the indoor units. Anytime you power up an indoor unit, the electronic expanse valve inside goes to fully closed. It shuts. It has to have a starting position. So say you go to pressure test and the electrician powered up all your indoor units. Where's your pressure test going to stop? Right at that EEV. There's a mode from the outdoor unit. We don't have to have refrigerant piping done yet, but we do need wire, low voltage and high voltage, everything. We can open all those back up. There's an additional charge mode. If you don't get all the charge in, you can use the compressor to pull the rest of the refrigerant in, because after you're calculated, after you get your additional charge, best time to add additional charge is under the vacuum. But say you couldn't get it all in, say some jobs, depending on how your piping is, you might have 100 pounds, 150 pounds you got to add. It's rare, but it depends on how long that piping run is. So there's a lot we can do from that outdoor unit PCB to help us, assist us. We can lock out units. Say you have a triple module system and for some reason you lost a compressor in one of those outdoor units. You can lock out that module and run the other two. And if I'm not mistaken, on 4X, you can lock out individual compressors. Now, these are emergency operation lockouts. We're not going to do it and leave it for 3 months. There's a reason a compressor dies. They just don't die. There's usually a reason. And it's usually something related to the install. And it's usually something related to what's in that refrigerant, in that oil. So a lot of stuff we can do from the outdoor. Now, if for some reason, during your initialization, the system sees a problem, it's going to give you a fault code. It's going to give you usually it's going to be a letter and then a number like an E1. This says E3, right? The first one, E3, I know it's hard to see. It says E3 right here. Then it gives you a subcode, 01. So in the service manual or on our app, you could go in there and put in E301. It'll tell you exactly what that code is. It'll give you a direction of where to start your troubleshooting. E301 on startup, I hope not, because that's a dead short if I'm not mistaken, but it's just an example. It's just an example. Mostly what I see on startup or commissioning are U4s. That's a communication error. It's usually something with the wiring. What I used to see, they don't let me out in the field much anymore. But it gives you a main code, then a subcode, and that's going to help you narrow down where to start troubleshooting. Because if you've got a triple module system and you've got, say, a high pressure sensor is bad in one of those outdoor units, how do you know which one it is? But that subcode will direct you toward the unit it has an issue on. So it's very, very handy. I mean, we have a service checker tool. I'm just looking at the time, guys. I'm getting close. We have a service checker tool where you can hook up from your laptop. It's a module. Then you hook the 2-wire to the outdoor unit, and we can see all the sensor values. We see about 45 points of the outdoor units, and we see about 7 or 8 points of each indoor unit. You can see expansion valve positions, rotations per second, fan RPMs, what valves open, what valves close, what this EV pulse value is. It gives you all that information. And we do have classes where we teach guys how to read that data. It's called Service Checker Level 2 class, so that we only do it in-house. We don't do it online because you need to be on the equipment to do it. But this is an example of a fault code. Now, ways to count indoor units, counting branch selector ports, now this says ports, because remember, we have multi-port boxes. When you count multi-port boxes, it's not going to count the boxes, it's going to count how many ports you're connected to. And it's a sequence of buttons. You want to count the indoor units so you know you have the right count. And that's a mode 1. We have a mode 2 and a mode 1. Mode 1 is where you're just looking at stuff. Monitor mode, you're just looking at it. There's a mode 2 I talked about earlier, refrigeration, recovery mode, force fan. That's when you make something happen with the system. So mode 1, you're looking at stuff. And it shows you what buttons to press and what you should look for. And in this example here, it's telling us, I'll just do the indoors because we're running out of time. Monitor mode, press BS1 one time, button one time. So you press the mode button, goes into mode 1, 0 0 flashing. You press the set button 10 times. So you hit the set button, the display will change to 10. Then you hit the return button. So that's telling me right there that there's 8 fan coils hooked to this outdoor unit or outdoor units. So if you know how many indoor units you're supposed to see, say it was 12, you know you have a problem. So then you could do that force fan mode, which is a mode 2 operation, and go inside and find which ones you're not talking to. And this is counting how many branch selector ports, difference between the two, the number of times you hit the set button. A lot of these button sequences are the same. The number of times you hit that set button tells it what function you're trying to do, whether I'm trying to count indoor, whether I'm trying to count BS boxes, counting outdoor manifolded units. How many do I have manifolded together? See how that's 13. So that's going to tell the PCB what you're trying to do, but the sequence is the same. Oh, sorry. Now this is the high static fan coil. Like I said, this is a toggle switch, lower high static. Turn it on, and if you want exact fan performance for that unit, you could look at an engineering manual, and that's available on Daikin City. But there's no field setting at the controller for this. Right here is a little toggle switch. It says high or low. That's how you change the static on that. That's a big boy fan coil, 6 and 8 ton. If you're in an area where you want to move a lot of air. Now the SQ and the MQ, they do have an auto static setting. This is a field setting you do from the remote controller. Okay, you do it from the remote controller, and you follow the sequence there on the left. It's in fan mode, so you're not pumping out refrigerant through the indoor unit. And it'll automatically adjust as static because it's looking at the amp draw of the fan motor, because we have no pressure differential switches in these fan coils. Okay, so it takes about 8 to 10 minutes. So it's going to adjust its static depending on what that fan motor is doing, the amp draw on that fan motor. So that's available on the MQ fan coil and the SQ. Those are the two like medium and higher static fan coils. What if that's not enough and you're trying to air balance, get more airflow? You can do a manual static setting. That's another field setting in the remote control. So you can do all of these static settings here, and you just change the code. You go into that field setting and you change the code. So if you want 56.56 inches of water, you would go to 11. So you can manually set the static. And that's available on the MQ and the SQ. So you can do it for either one of those. And like I said, that's done from the remote controller. And this is showing the SQ. They look all similar. If you look at the two, they look a lot like. It's difference in statics, if I'm not mistaken. The SQ is newer. We had the SQ when we first came to the US. We went away for a while, but we redesigned it and brought it back. It's a good fan coil. It's a good indoor unit. But you can also do a manual static setting on this. So it's very possible. The FXDQ, this is the low static. You can go from standard, if you see in that bottom one there, setting a static from standard to high static. You're not getting a lot off this. I think the 2 ton, you can get up to 0.24 static. You're not going to be running 100 feet of ductwork off of this thing, okay? It's low static. It's designed. I see a lot of them in the hotel rooms where they have a short run of duct, where they just have a supply grill and a return grill, and that's it. Very quiet fan coil, very quiet, good for hotel rooms. Now, Test mode. Every VRV system, once you're done, once you've counted indoor units, you've got all the wiring, everything's done. You counted BS boxes, you've got the charge in it, the additional charge. You're ready to turn it on, but you can't turn it on because you go to the controller, you hit on, and it gives you a U3 code. U3 means you have not ran test operation. So you've got to run test operation for every VRV system. So all you do is go, it's real difficult, stay with me here. You go to the outdoor unit, the PCB, the BS2 button, you hold it for about 6 seconds. Once you see these red lights come on, it's going to say T01. It's in test operation. Let off the button, let it go. It's going to take, I've seen them take 35, 45 minutes. Depends on how long your refrigerant piping is, how many indoor units you have, if it's a double, triple module. Just let it go. The remote controllers are locked out. They can't do anything at the controllers. It'll say centrally controlled on them. They can hit them all day long. It won't do anything. They're locked out, okay? Make sure when you put it in test operation that all the remote controllers are off. You don't need them calling for anything. But once it's in test operation, it's locked out. They can't do anything. And let it do its thing. Put your doors on the outdoor unit so you're not bypassing the outdoor heat exchanger, the outdoor coil, all right, you know, and just let it go. What's it going to do during test operation? All those features right there. It's going to cooling startup, cooling operation stabilize, communication check, stop valve check. It's going to check to make sure your stop valves are open. Refrigerant piping length check, refrigerant charge check. If you usually get to 07, if you get past 07, T07, you're usually pretty good. There is no 8 and 9. That is for a leak check function for the European models. We don't use it in the US, okay? But once you get past 7, you're usually pretty good to go. But this thing is going to check its refrigerant pipe length. It's going to look at subcooling and superheat of that system. It's going to, you know, it does a lot. So every VRV system, be it a VRV4S, be it a water cooled, be it an air cooled, be it a heat pump or heat recovery, has to be ran through the test mode so it can operate. We can bypass the test mode. I'm not going to tell you how. But if you do that, in certain situations we have, but it takes 10 days for it to set up its parameters. Because during this test operation, it sets up target evaporating and target condensing temperatures. It's going to try and reach every time it operates. Those aren't lock set dead values. They will change during different loads, different outdoor temperatures, but it sets those values up. So every VRV system has to be ran through test operation. Once you get done, you get down here to blank screen, you're good to go. If you have a fault code, you need to figure out what the fault code is. It'll tell you, fix the fault code and run it through test operation again, okay? All right, so that's a really quick overview of VRV. There's so much more to it. We have training available. Our training is at no cost. We don't charge for training, and we're doing webinars now. So if you guys are interested, I'll get with Ray and see if he wants to send out my links to you guys. But that's a quick overview. And now I'm going to open up Ray here, and we're going to look at any questions we have.
All right. Thank you very much, Mark. So we've got 11 questions here. We're going to have to try to take these in somewhat rapid fire mode. I'm just going to the order that came in. The Daikin VRF system, in my commissioning experience, does not always link up to a building management system to see all points in the VRF. Is there any technical assistance we can access when the submittals are provided prior to construction?
As far as for a building management system, it's usually going to go through a BACnet or a lawn if you're using that. And we have a BACnet design guide and a lawn design guide. I also have control specialists in the call center that can help you out. We also have a controls class that is available to take on that. But if you're going through another BMS system, that's going to be, because all we do is set up the BACnet. It's a gateway. It sounds like a controls guy on here. It's a gateway. It's a translator, right? It translates the Daikin to whatever front end, the Allerton, the Johnson controls. But yeah, and when our techs go out there, we just set up the BACnet along to talk to that system, but they're not front end guys. They don't know it. I have a controls department that can help you out with stuff like that if you have those kind of issues. But we do have controls guys in the call center that can help you out too. So you could call our call center hotline and then tell them what your situation is. If they don't know the answer, then they can go to the controls people to help you out. Sometimes the controls guys just call you because some of our techs don't speak that front end talk. So, but yeah, if you have issues with that, go on Daikin City and look up the design guides for the backnet and the lawn. They may help you with some of the numbers that you're used to looking for. I hope that answers your question.
Great. Thanks, Mark. Second question, I understand the piping of a VRV is very specific to the installation. What can be done for future expansion or changes?
So with VRV4X, we do allow for future tenant improvement. In fact, in the class, the guys teach it as far as putting stop valves in, and then later on adding fan coils or adding even another outdoor unit. And we've adjusted it too. So say you have a double module and you know later on you're going to add a triple module. There are certain tonnages, if you stay within a certain tonnage rate, you don't have to change that main pipe size that goes into the building. So that is taught in our class, and we can do that. And whoever does, if you're doing VRV and you're doing a Web Express, that can be put into the Web Express program, future expansion, and it'll actually show you where the stop valves go and what pipe size you need, everything. So that's a feature that's built into the Web Express.
Great, thank you. If a Y joint is installed vertically, will the top or bottom branch be starved of refrigerant?
No, if it's vertical like this, you're fine. It's when it's horizontal and you're more than 30 degrees. It's going to starve that lesser branch, or whichever one's higher. It's going to starve that. But this way, whether your condenser's below going up or your condenser's down, as long as it's like that, no problems. We've never seen problems like that. Now the header, on the header, remember, that's got to be the multi-port header, that's got to be flat and horizontal. You stand it up like that, you're going to have problems. But the Y joint, now this way or this way, no problems.
Okay. Please cover how the VRF system can provide alarms to the facilities staff when it notices small refrigerant leaks.
Well, we don't sense for refrigerant leaks. What you'll probably see is, depending on how big the leak is, you're going to have performance issues. Of course, you know, your rooms aren't going to cool off enough for heat well, but there will be other codes that would pop up in the system as far as high discharge pipe temperatures. Depending on which code it sees first, but we don't monitor as far as refrigerant leaks. We monitor through the sensors. We have a lot of fault codes that deal with wet operation, which would be too much refrigerant, and low charge. You would see, you know, high superheats at the fan coils. You would see high discharge pipe temperatures out there. But as far as monitoring leaks, and we have low and high pressure sensors also on the system. Every VRV system does. So if those see a certain value, they'll trip out and give you a fault code.
Okay. Is condensate pump a Daikin option with horizontal ceiling fan coil units?
Horizontal ceiling fan coil units. I'm assuming you're saying the ceiling hung one. I said that hungs underneath. That doesn't have a lift pump in it, but you could add. We sell. Well, we don't sell. We have a vendor, Aspen Pumps, the mini pumps. If it's the vertical, yes, the ceiling hung, it's called the FXHQ. That mini blue, because you could use a mini blue aqua pump on there. They'll fit in that fan coil. The return doors flop down like this, so your fan motor's here, but you've got space to put it in there. But as far as that, we don't have a pump that goes in there. It's a third-party pump, but you can get them through Daikin. It's the mini blue. There's also a maxi orange, but you can put that pump. In fact, I've installed them in my labs inside that fan coil where you can't see them.
Okay. Do you have any type control system gateway to allow backnet communication between Daikin system and a building BMS such as JCI?
Well, that would be the backnet gateway. Yeah, I mean, if you're talking about Daikin backnet to JCI, that's how we integrate with JCI. See the backnet. Am I misunderstanding this question? Because I've started up many, when I was in the field, I started up many backnets, and we integrate with Allerton, Johnson Controls, hence, you know, what's Automated Logic. But that would be the gateway, because when we set up the gateways or the backnets, we of course put an IP address into it, instance number. If it's a foreign device on the network, we set it with a foreign device. We just set it up so the front end can talk to it. We don't, my guys or the guys, our techs in the field, we're not front end guys. We just set it up and we make sure that the front end people can talk to that gateway. Once they can talk to that gateway, it's all up to the front end people. But I hope I answered that question. Do you have any type control system gateway to allow backnet? But we have backnet and LAN to interface. There's probably more control features. I knew there's some Modbus stuff going on now. I'm not into that. If you have questions on that, I would look on Daikin City and go under controls and see what's coming out. But I know there's Modbus. I think there's some adapter PCBs, but if you're just talking about gateways, we have BACnet and LAN, and we can't interface with most control front end systems that I know of.
Okay. If the IDU controllers have heat cool auto settings for an HP non-recovery system, do all the controllers have to be set in the same mode for the system to function properly? For example, with 10 IDUs, 9 in auto, 1 in heat, would that cause an operability issue?
No, because when you first say a heat pump's got 10 indoor units, okay? After you run that heat pump through test operation, you're going to walk inside and say you have 10 controllers. Each one of those controllers will be flashing master controlled ED at the end of it. The first one you hit the mode button on becomes the master. You can say the master's in heat mode. At the sub controllers, you'll have heat and fan only. You won't be able to select cool. If the master's in cool mode, you'll have cool, fan, and dry mode available at the subs, okay? If the master's in fan mode, you only have fan available at the sub. So there's no way you could select heat or cool at the same time. You wouldn't be able to do that. Changing the master is real easy. So you have 10 controllers. 9 of them will say master controlled on the controller. There's one that won't say it. That's your master. If you want to change it, you go up to the master, hold the mode button down for 5 seconds. Master control will start flashing on all the controllers again. The one you want to become master, go hit the mode. Now that's your master. So you can't run heat and cool. It doesn't give you the option at the controllers.
Okay. What is the best way to shut down the indoor units for fire alarm?
Like I said, T1 and T2 is not fire life rated. Okay. So that's a controls thing. Our iTouch manager has shut down, but I don't think that's fire life rated either. That is what I don't know. I know they were going to update that because T1 and T2, you could shut it down, but like I said, it's not fire life rated because somebody could go to the controller and turn it back on. They could change the setting on it. That's a good question. I do not have that answer for you. I mean, best way to shut them down, I would think fire safety, and you don't want to daisy chain T1 and T2 because there's no voltage. You'd have to do isolation relays at each one. I would have to ask Norman Pennant that question and what they've come up with lately on that because I do not know the answer to that question. Sorry, but I don't.
Okay.
I can get back to Ray on that if need be. I can check with the controls division, see if something new is coming out or something.
Let's do that, Mark. And then anything else that you don't feel like you're the best person to answer.
No, I'm not gonna tell them something I'm not sure about because I don't. That's an important question because it's talking about fire safety, and I don't want to say something that's wrong and then something happens.
Absolutely. With COVID-19 concerns, ASHRAE is recommending minimum of MERV 13 filtration. Can Daikin provide this for all of their indoor unit product line?
Some, but not all, I think. I know the cassettes you can, ducted, of course you can, but I don't know about some of the, like the wall mounts and the ceiling hungs. I don't think we have MERV 13 for everything. I hate to keep saying this, but Daikin City, you could go look at the fan coils and there are options for those indoor units that'll tell you if a MERV 13 filter is available. I know we do for some, but I don't think for all. Not yet.
Mark, what we can do is on some of these things, links to some of the things you've mentioned, especially the more general ones. If you want to provide us a summary, see if we can include that information and send that out to people who registered.
Okay.
When we follow up with them later for the recorded version of the webinar and things like that.
Right. Like I said, I would just need a list of these questions. Can you print out a list of these questions?
Yeah, Duffy is on, and he'll pull all the questions that are here.
Okay, because then I can just send them to the people that have the answers, and then I can send them back to you guys.
Exactly.
All
right. If the system lost power, do you have to reperform the test operation or startup cycle? Many jobs will have temporary power, and then startup will be addressed before permanent power.
You do not have to redo test operation. What will happen is if you lose power to the outdoor units, when they come back on, they'll reinitialize that 8 to 10 minutes, then they'll go back to whatever the last setting was. Test mode, in a perfect world, test operation, you should only have to do it on the first time you start that system up. But anytime you, like say there was a leak and you had to adjust a charge in the system, or you, for some reason you lost compressor change, or you added fan coils, anytime you adjust that refrigeration circuit, I would rerun the test, but not on a power failure. Just have to reinitialize and it'll come back up to whatever it was before.
Okay. Cutting this down, we're down, got it down to 9 questions. What is the lowest outside air temperature for operation looking at Northern Canada? And 2, what is the minimum testing outside air temperature that will not harm the units?
Well, I think VRV4X, I think it's rated down to -13, if I'm not mistaken. What is the minimum testing? Outdoor air temp, not harming the units. As far as the test operation, if it's too cold inside the building or outside, it's not going to get through test mode. It's going to shut off and give you a fault code. It's rare it does that. There are ways we could bypass and run the heat for a little bit to warm up the space. And I know the call center is very popular with that, or they do that a lot. And then it's a lot to deal with indoor temp too, not just outdoor temp. But as far as the rating, outdoor operation range of VRV4X, I'm pretty sure it's down to -13, if I'm not mistaken. Yeah. But you could, like I said, engineering data on Daikin City would definitely, but I think it's -13.
This will probably have to be kind of a summary answer, but please explain the refrigerant charge auto test.
The refrigerant, you mean where it tests refrigerant charge? Oh, okay. Well, it's going to go out, it's going to look at, yeah, that's a long discussion because it does a lot. But it basically is looking at subcooling and superheat throughout the system in certain areas to figure out if the charge is proper in the system. Because during test operation, if you're standing by a unit during test operation, you'll hear that compressor. It's going to ramp up and ramp down, and it runs at 2 extremes. It shoots for TEs, target evaporating temperatures of 5 degrees at times. So, but it's basically going through the system. Since we have sensors all through that system, it's looking superheat and subcooling. Remember, it does it in cooling only. So it's going to look for subcooling outside and superheat inside. There's certain definitions of it, of what it does, but I'd have to have in front of me too. But that, in a roundabout way, that's what it does. It looks at all those sensor values to see if the charge is proper. You know, indoor unit, you have liquid and gas sensors on each indoor unit. On the outdoor unit, I think I've got 14 to 15 sensors. So we're looking at subcooling, superheat, discharge superheat. We also look at that. Discharge pipe temperature tells you a lot. But it's basically looking at all these sensor values to make sure the charge is proper.
Okay. This might be reiterating something you already addressed, Mark, but what is the difference between VRF and VRV?
An F and a V. No, I'm just kidding. Variable refrigerant flow and variable refrigerant volume are basically the same thing, but VRV is Daikin's trademark name. That's the difference. We are the only ones that call it VRV. We're the only ones that can call it VRV, but it's basically variable refrigerant flow, variable refrigerant volume. It's basically the same thing, you know, as flow as the volume. So not much difference there.
Q-tip, cotton swab. On the cassette indoor units, we are sometimes low on outside air. There doesn't seem to be anything we can adjust as tab agents. Is there a way to reduce return air on these units?
As far as fan speeds, CFMs, on the cassettes, I know you can increase it. I don't know about decreasing it. I know we can change the value for ceiling height. So if a cassette's like between 10 and 12 feet, 12 to 13, we can increase the fan RPMs. But I don't know of a way to decrease it. Not as far as fan speed, as far as your return air, and you can't block it off. Because there's kits for those cassettes to bring in outside air. You have a single input, and you also have a dual pipe input, where you can bring in 2 pipes that go to 1 pipe out there. As far as the Venturi kit, and that's in the options on Daikin City. You could look at that. But to reduce return air on the cassettes, I'm going to have to say no. I'll double check, but I'm going to have to say no on that. Not that I know of. Not that I know of.
Okay. Samsung has an IP address to access the points for their VRF. Does Daikin as well?
Samsung has an IP address to access their points for VRF. As far as the service checker, as far as points, or that's a controls thing that would probably be through the iTouch manager we have. I'm sure we do, but I don't know. I'll give me that question. I'll check on it, but I'm sure we do. I'm curious as to what points the question is referring to. That would be, I mean, are you talking about sensor values? You talking about, or controlling features, like through a front end, how to control, you know, set temperature, you know, fan speed and stuff like that. That would be my question on that. If you could, if somebody could respond to that and clarify that, that would be nice.
Okay. What should the orientation of a distributor be that feeds the DX coil? Vertical, horizontal, or it doesn't matter?
You mean the Y joint, the Refnet? I'm assuming that's what you mean by distributor. Doesn't matter, but if you're going into a fan coil, they're usually in the horizontal position. We're talking about the Y joint or the header. Remember, horizontal, we don't want to tip it either way. If you're going vertically and you come in and bend into the fan coil, that's fine, because remember, you're going to have two pipes off that joint, that Y joint. One's going to be your main line continue on, and you can do that, and you could come up. Just keep in mind, I always tell guys this, off of the Refnets, the Ys and the headers. Refnet means refrigerant network device. You want to give yourself about 20 inches off of either end before you 90. Okay. The reason for that is if you do it, say I have a Y joint right here and I put a 90, somebody can see my hand. This is my Y joint, right? Say I 90 right off it, 90 right here and 90 right into it. Those 90s, I guarantee you, are going to cause turbulent flow, and turbulent flow means noise. Okay. And we don't want noise. So you want to come 20 inches off before you 90 in or out of a Refnet. But you can have them vertically and then come up and turn into a fan coil. That's fine, you know, but most I see are in the horizontal. In horizontal position, get them as flat as you can. Trust me. That's the best way to do it. It's the best way to do it.
Okay. Can you expand on dry mode? As a commissioning provider, attempting to find detailed sequences for dry mode is very difficult.
Yes, it is, because it doesn't, okay. Dry mode. Now there's two things of dry mode. Dry mode is basically, all right, on most of our fan coils, say you select dry mode on the remote control. At the time you select dry mode, it looks at the return air temperature sensor, okay? And 76 degrees is usually the balance point, okay? So if I put it in dry mode and it's above 76 degrees by that return air sensor, it won't drop the temperature into the space more than 2.8 degrees. Once it gets within that range, dry mode shuts, the EV shuts, it'll let the temperature rise up. So it just goes in and out of that range of 2.8 degrees. If that return air temperature is below 76, it won't drop the room temperature more than 1.8 degrees. And all we're doing is slowing the indoor fan speed down so we can get more moisture out of the room, okay? It won't show you a set temperature on the remote controller. It just says dry mode. Now, with the FXTQ and the CXTQ coil, there is a dry mode 2.0, where instead of looking at the return air temperature to run that dry mode, it looks at the set temperature or the room temperature from the controller. And that's a field setting we can change, but it's just on those two fan coils. The FXTQ, the vertical air handler, you know, and then the coil that sits on top, but all the other fan coils, and they will be getting its the new dry mode eventually. But it basically works off of that. That's a generic way, but you can't shoot for any relative humidity. I can't tell you what it's going to do, okay? It's just working off that return air temperature. There's only one system we sell that you can select a relative humidity, and that's a quaternion, and that's a mini split. I mean, that's a basic explanation of it. We get into it a lot more in our training class as far as dry mode. Yeah, but dry mode, depending on what part of the country, you know, I wouldn't use it to cool a space. I would cool the space down with straight cooling mode. And then if they want to run dry mode, get the space cool, then run dry mode to maintain it. But basically, you're slowing down the enforced fan feed to increase the coil area, but it works off of that return air temperature at the time when you put it into dry mode.
Great. Coming down to our last few here, Mark, is it normal to see indoor coil superheat hunting on a VRV, VRF unit, or should it hold a steady temperature?
Good question. Depending on, once it's been running 15, 20 minutes, remember this ain't the, you know, this is a system that has many indoor units, okay? You might have long refrigerant piping. I wouldn't turn it on and then 5 minutes later go in there and look at the superheat. I would let it run for about 15, 20 minutes, then go in there and check your superheat. Okay. If it's charged properly, you've ascertained to all the piping rules, and you have proper flow, you're going to maintain 9 degrees pretty good. Okay. But it's going to take a while to get up to that. It's, like I said, I wouldn't go in there right away. And what I usually do when I was on site, I would go to the nav controller. I would put it in that field setting where I can look at those sensors, and you can just leave it in that field setting while it's running. You can actually watch it as that superheat starts to get closer. If you have refrigerant flow problems, not enough, you're going to have a large superheat. If you got too much, you're going to have a low superheat. Or if they didn't use nitrogen when they brazed, which is key, they might have trash in that system that screwed up the EVs. Now we have electronics expansion valves in each indoor unit. And that thing, if that head is scratched up in there, it's not going to seat properly, and it's going to bleed liquid by when that thing's supposed to be closed. And that's a great thing about the nav controller. If you think a fan coil's bleeding by, you think you have a bad EV, you could shut that fan coil off, right, and run the other ones, right, because there's still flow going through the system. And if you see any temperature change on those two sensors, if that liquid line sensor is still good and cold, that EV is bleeding by when it's supposed to be at 0 pulses. Oh, and I forgot to mention, you can see the EV pulse from the nav controller also.
All right, coming down to the last 2 questions. Is there a guide to indicate what the max MERV filter is, say MERV 8 or MERV 13 or higher, that can be used with various indoor modules?
Yes, that would be on Daikin City under options for whatever fan coil you're looking at. That would be where you would look at it. Yeah, that's the best answer I got for you on that one. Yeah. But yeah, if it's available for a fan coil, if you're on Daikin City, you can look up model or look up certain fan coils, and there's always an options or accessories tab. You can go there. If there's an accessory for it, it's in that list.
All right. Last question. Is there any projection using PEX pipes later?
No. Not yet. No. There's a lot of stuff out there, and if I have a second, Ray, let me cover this because I get a lot of questions about things on this. There's a lot of things outside, aluminum piping, copper piping, brazing, compression fittings, leak lock, stuff like that. If brazing is done properly and flaring is done properly, brazing joints are stronger than the copper. I know a lot of people, because brazing is an art form. I agree with everybody. Good brazier is hard to find. And guys that do it well are paid well. Med gas guys are usually the best guys. They have to. We actually offer Brazing courses at DTTP. It's actually a 4-day course, and you're taught by the factory trainer. We're not doing it now because, of course, of COVID. But we're looking at joining with schools, like trade schools in local areas. I think our first place is going to be New York, where we're going to partner with one of the local schools, I think it's Suffolk County, to have their instructors taught by our Daikin factory people to do brazing. But right now, copper pipe, we don't really say you can't use aluminum pipe. We don't say you can, we don't say you can't, because I know what's going on out there. Aluminum pipes being installed, because Reflock is a third-party component. Now, yeah, PEX, I haven't heard anything about it. Shark bite, people ask me about shark bite, that's a connector. Compression fittings, Reflock is kind of a compression fitting, and there's other third-party stuff out there, but you got to be careful about using stuff like that, because if you have leaks on the system, I don't want people running into trouble with warranty because of a third-party component. So if you're doing any Daikin install, check with your Daikin salesperson, please. Make sure they have an idea of what you're using or what you plan on using, like leak lock. We don't need leak lock. Guys who use leak lock or refrigerant piping aren't doing it right. On the flare fittings, you don't need anything. A little bit of oil, that's all you need. Leak lock on a flare fitting, the first place that leak lock is going to go is in those EVs, and those are microscopic openings, and all you're going to do is cause problems. In my refrigerant piping, all I want is refrigerant piping and oil. Or inside, excuse me, I want refrigerant oil. That's all I want. I don't need anything else. We do, if you have a burnout for some reason, we're going to have a filter assembly kit. It's a bypass circuit that you'll be able to buy from us. It's a kit. We're working on that right now. But if you do the install right, you do the pressure test, the evacuation, run nitrogen when you break, dry nitrogen, do the evacuation down to that, our triple evacuation, last evacuation down to 500 microns or below. You do all that right, I guarantee you're going to have less problems. I guarantee it. I preach piping all the time. I don't mean to get off on rant here, but that's one of my things, because I was in the field for 10 years, and most of the problems I saw is guys weren't using the right stuff. They weren't pressure testing right. They weren't evacuating right. These aren't the days where you evacuate down 150 PSI, or excuse me, pressure test 150 PSI, then vacuum it for an hour. Oh, the vacuum pump changed noise. It's time, I'm done. That's not the rules. You got to use a micron gauge. It's the only way to tell it a proper vacuum. Your manifold set doesn't do it. You got to use a micron gauge. But I'm getting off my soapbox.
All right. Well, thanks very much. That was the last question. Thanks to all the attendees out there for all the great questions and for sticking into the end.
Yes, thank you. Thank you very much.
A few wrap-up notes. Please join us next week for the next webinar, Effects of Temperature Change on Building Static Pressure Measurement. For those of you who attended this week's and any of the others, give us about a week to 10 days. We'll get your continuing education certificates out to you, and then we'll also have the sort of on-demand recorded version of these seminars available to those of you who registered, so that your colleagues can also view them if they were not able to make it today. But that's all I have for now. Thanks very much on behalf of AABC and its membership and its leadership. And thank you for being here. And we're just going to play you out with a little AABC video. Thanks very much. Have a great afternoon.
Thanks, everybody. Appreciate the time.
The Associated Air Balance Council, the world's oldest and most respected association of certified, independent test, adjust, and balance agencies. AABC offers its members and the industry technical education and training, an ANSI-approved TAB standard, and a variety of resources with the goal of ensuring that systems are tested properly and operate as designed and intended. Let's take a look at why independent test and balance is important and why AABC certified agencies are the service providers of choice for every building owner and design professional.
The testing, adjusting, and balancing process is a benefit in many different ways to the owner. That not having the process done may save some dollars on the front end, but the process in itself is all to make sure that the owner receives what he paid for.
For my customers who are either building owners or operators, independence matters because they're getting an unbiased view at their mechanical install, at the design, and actual end performance of the equipment that they're having tested and balanced.
Well, they just get a better product. They get somebody who's looking at all the pieces and how they all tend to work together.
For me, independence is more about trust than it is anything else. Knowing that when they come into the room with a problem and they've got an independent entity as a tab agent and they know it's independent because they're certified by AABC is the most important part to the process.
They're high quality, high caliber people who are extremely driven to make high energy efficiency buildings and make an impact on what really is the demand of the future, which is the energy market, and how do we make sustainable buildings. And I haven't seen a group of people at any of the other organizations that have that knowledge base that AABC brings to the table.